All right, in this video, we are going to do part 2 of the wastewater management class survey example. So in the last video, we got up to where I have you guys now calculate the slope of the sewer main in the street. Now we're going to get the length of this sewer lateral, or like the distance from the northern house. Oh, I think I said that wrong. Okay, over here is where we're doing that. Okay, let's backtrack a little bit. Now we're going to find the distance from the northern manhole to the invert in front of the northern house where it's going to be connecting to the main. So basically from here, this is the northern manhole. How long is it from here to here, roughly? So if the overall length we said was 280, again, you would calculate this if you actually had the real survey in front of you with the scale, but that would be 1, 2, 3, 4. It's about 1/5 of the distance, roughly. Let's just say 50. It's 50 feet away. So the distance from here to where the sewer lateral will be from this northern home, it will be 50 feet. And let's do the same thing for the southern one. It seems to be a little bit further. So let's call that 80 feet from here to roughly here, wherever that sewer line is that will connect to the house. Let's call that 80 feet. Okay. You guys will then have to calculate the invert in front of the house. So you should remember how to do that. You know, your starting elevation, and then you're subtracting whatever that slope is for that many feet, and then you can get what the invert of this sewer main is in front of each of these houses. Things to know is that from here, you are subtracting. And if you're going from here, you're actually adding because you're going in the opposite direction back uphill. Okay? Now, some other thing to know, and this is important because it'll be on your quiz. We actually don't like to connect our house lateral to the bottom of a pipe. I know in class I kind of showed you that because that is going to be our worst case scenario. And it technically does work, but it's not ideal. Imagine if you tap into a main pipe right here at the bottom. When this is flowing relatively full, then there's going to be a lot of water that actually starts moving back towards and is always in the lateral, and it creates turbulence. It can create clogs more likely. It's not ideal, although it is acceptable. A better design is to tap in at least halfway. So that would make the invert at this point right here, the invert of the pipe plus half of the diameter. So if this was invert 100.00 at the bottom, and this was a 6-inch pipe, then you have to convert it to feet. So a 6-inch pipe would be 0.5. The invert right here will be 100.5. It's the invert at the bottom of the main plus half of the diameter of the pipe. That's better. The best design is to tap it in at the top, actually. So from here, the invert of the ending elevation of the lateral is going to be the invert of the main plus the full diameter. So if this is I think I said this one wrong. This one was wrong. I said 0.5. It should have been 0.25. So this is 100.25. And here, if we have a 4-inch pipe, and this was invert elevation 100, this would be 100.33. Let's go back to this one real quick. If it's elevation 100 right here, and it's a 6-inch pipe, then the elevation ending right here would be 100.25. Okay. Okay, now let's look at what the design elevation is of the invert. I should say design elevation of sewer main invert. Okay, all this is saying is you calculated what the invert is at the respective locations. You calculate what the invert is right here. And now let's just add the diameter of the pipe. So this pipe is an 8-inch pipe. I know that because it says it right here. So all you're going to do right here is take your answer from here and then add 0.66. Because that'll give you the invert of the top of the pipe right there. So take your elevation and then add 0.66. Okay, distance between the house and the main. Let's say it's, if I say that was 50, let's call it 25. 25 feet, and that'll be for both of them. All right, next we're going to get what the slope would be naturally. Like we're starting at elevation 14 for our invert leaving the house. We're starting at 14. We are ending at wherever you calculated right above it, right over here. So you're just getting the slope. Starting is 14, ending is over here, and then you're dividing it by 25, and that'll give you the slope of the natural invert. Now you can, go lower than that, but really that's like the maximum that you can do. And then the same thing for the southern one. You are starting at this elevation, which is 14. I think we calculated that. Oh, no. We started at 14. We're ending at wherever you have over here, and then you're dividing it by 25. So that's what you're going to be doing for those two. And then finally, if that all works, you're going to look at the chart and figure out which pipe diameter you would use. And then you're going to use the slope from the previous one over here. And that'll be your final answer. So I think this is only a 16 DFU pipe, which is pretty low. I imagine a 3-inch one will work, but you'll have to be able to prove that as well using the chart. And that's pretty much it. All right, I will see you all next class.